developers, and welcome to a new open class, open class number 147. So welcome everybody. And today we are going to be talking a little bit, as you can see in the title of the open class, about Gazebo and the relation, some of the relations that Gazebo has with ROS. Some of these connections, we are going to explore them. So, yeah, welcome everybody, and please, first of all, as always, let me know if everything is fine, if sound is fine, if video is fine, so that I can continue my class without worrying about it. Everything should be okay, I'd say. So, yeah, I'm going to be checking the chat here, and let me switch already then to my computer screen so that I can start the open class and have access to the chat directly here myself. So yeah, let's get started right now. And as always, I'm going to change here to my computer screen. There we go. So let's log in. As you can see, the platform has changed a little bit. All right, here the left menu. In any case, the open classes, you are going to find them now. Of course, you have this button, which takes you directly to the open class, but also, if not, you can come here to the self-learning area. And in open classes, you're going to have access as well to the class. So let me mute myself here. I have access to the chat here, no messages, so I suppose that everything is going fine. If not, please let me know. Write a message here in the chat and I'm going to see it. And yeah, the first thing to do is, as always, to get the class rosject, the class project. So for this, hello, I can see there Ronak is saying hello. Welcome to the open class. As always, the first thing to do is to get the rosject. So let's click on the button here, which is right above the chat, in order to fork and open the class rosject. So I'm going to do it myself here. There we go. And this is going to, you were quite soft, but I leveled it up my own volume, says Arnold. Okay. Is it extremely loud sound volume or it's just me? Maybe you can raise the volume here. Let me see. I'm going to increase a little bit the volume from here. Better now? Hello. Is it better? Hello there. Do you want me to increase it more? There we go. Perfect, says Eric. Okay, is it good now? Yes? Okay. All right, much better, says Arnold. All right, great. So Ronak is asking, will we get a recording of this session later? Yes. As always, all the open classes are being recorded and they are going to be uploaded to YouTube. Yeah? So you are going to have them available on YouTube later. So yeah, my rosject, as you can see here, is already opened. So all of you should be in the same page as I am. So you should have your rosject opened, and as always, you have the notebook available here. Make sure that the notebook is for the open class number 147. Yeah, have you been able to get the rosject properly? Are you already in the rosject page? Yes, says Mario. Yuhung says also yes. Perfect. Then, yeah, so today we are going to be exploring, as I was saying a little bit, some basic stuff. Really, it's some basic stuff, essentials about Gazebo, and more in particular of some of the connections that Gazebo has with ROS. Okay, so we are going to start here by launching an empty world simulation in this case. Yeah. So like Arnold says, the first thing we are going to do is to launch this empty world simulation, and you have the commands to do it right here in the notebook. Okay. Then, as always, what I suggest is that you copy the commands directly here from the notebook. You can copy them and paste them into a terminal. I have already one open here. In case that you don't, remember that in order to open a new shell, a new terminal, you just have to click in this icon here. You have the image right here in the notebook. It's the first icon that you have right here. And by clicking on this is going to open a new blank shell terminal. Okay, then in here you can paste commands, like for instance this one, which I am going to paste right now, in order to source the Catkin workspace of my project, and then I'm going to also copy and paste this ROS launch command, which, as you can see, it's launching this empty world launch file. Okay, so let's execute this command, and this is going to automatically open the Gazebo client here, and you should get a Gazebo world which is empty at this point. Yeah, it has nothing on it. So yeah, we have started this empty Gazebo simulation. Yeah. So in case that you are curious and want to have a look at this file, what it contains, etc., for this you can open the code editor, which is this second icon here. Yeah, it's right at the side of the web of the shell icon. Then this opens the code editor, which is an integrated development environment with a graphical interface that is going to give you access to all the workspaces and folders and files that are within this rosject. In this case, we have sourced the Catkin workspace, and we are using this robot description package. And in particular, from the robot description package, as you can see from the command, we are running the empty world.launch. So if you go to the launch folder of this robot description package, you are going to find this empty world.launch. Yeah? So here you are going to see the launch file that we have just executed. Yeah, as you can see, it's a launch file which it contains an include of another launch file, which is this empty world launch, provided by the Gazebo ROS package. Yeah, this is just a launch file that is going to start an empty world, as you can see, with nothing on it. All right? So, our create a spawn, yeah, this is the next step. Yeah, we are going to be doing, I'm going to be doing the steps so that you can follow. So I'm going to be doing everything, okay? So you should be doing everything that I am going to be doing. I'm going to be following this notebook step by step. So I encourage you to please do the same, okay? This is why we are sharing this project with all of you, so that you can have it and you can replicate and do all the practical part that I'm going to be doing. You can do it yourself also, yeah? So, so yeah, as a requirement, but also during this open class, we are going to be seeing some basic concepts related to Gazebo, but in case that you want to learn more and really get deeper into Gazebo and get a more advanced knowledge, you have this course in our academy named Mastering Gazebo Simulator. You have the link here, which it's a much more complete course. Of course, in open classes, we have limited time, so we have to teach something very specific, but here you are going to get a full knowledge of all the basics or the most essential parts related to Gazebo. Yeah? So, yeah, then with the proper introductions being made, let's start. Then the first thing that we are going to do is to spawn a robot in Gazebo. We are going to spawn a robot into our Gazebo, which right now it's an empty world. So we are going to spawn a robot in Gazebo, but we are going to do it using ROS nodes, okay? A ROS node. So for this, we are going to create a new launch file, okay? And we are going to create this new launch file here, of course, in the launch folder, yeah? So in our Catkin workspace, inside the robot description package, and we are going to place this launch file inside the launch folder. So let's You can create it here directly through the code editor by right-clicking on the folder that you want to create the file, and then selecting new file and specifying a name, which in this case it's spawn.launch. All right? So this is going to create this spawn.launch file, which is empty right now, and then the next step is to fill this file with some contents. And we are going to fill it with the contents that you can find here in the notebook. Yeah, so let's select all this, copy it, and paste it into our file. All right? Then let's have a quick look at this, because so what are we doing in this launch file? Well, first of all, we are specifying a parameter named robot description, and we are assigning a value to this parameter. The value of this parameter is going to be basically the contents of this robot URDF file. Okay? In a moment, we are going to have a look at a very quick look at this file. But if you have some experience in ROS, you might know that robots are defined using URDF files. All right? So basically, we are loading the contents of this robot URDF file into a parameter named robot description. All right? Then we are defining some other arguments for X, Y, and Z. These arguments, we are going to use them to set the coordinates where we are going to spawn the robot into the Gazebo world, right? And then finally, we are starting a node, a ROS node. Yeah, we are going to start a ROS node from the Gazebo ROS package, which is named spawn model. This is the ROS node that we are starting, spawn model. Yeah, and this ROS node, it's defined inside the Gazebo ROS package, which is installed by default with the ROS and Gazebo installation. Yeah. Then this node asks for some information. Yeah. So as the name itself says, the purpose of this ROS node is to spawn a model. In this case, to spawn the model which is defined in this file, which is our robot. So the purpose of this ROS node is to spawn a model into Gazebo, right? This is the purpose of this ROS node. Then in order to do so, it's going to ask some data. Like, for instance, it's asking us a robot description parameter with some data. Why? Because what this node is going to do is to get the data from the robot description parameter, which is the data from this robot URDF file, and then it's going to use this data from the URDF file, which contains the definition of a robot, and then it's going to spawn this robot into Gazebo in the following coordinates, X, Y, and Z, which we are defining here. Yeah? So far, so good? Are you following? Yes? Does it make sense? All good, says Mario. Perfect. This is also explained here in the notebook, all right, as you can see. Then what we are going to do right now is to open another blank shell. Yeah? So in order to do so, you can click here in this add icon, which says create new shell. So if you click here, this is going to create a new shell. Yeah? Don't stop the first one. This one we are going to leave it here running, okay? Because this one is the one which contains the process that it's running this empty world. So we are going to open a new one, and in this new one, in this new blank shell, we are going to run this command. Yeah, so you can copy it again directly from the notebook and paste it here. So we are going to execute the launch file that we have just created, this one here. Yeah. So this launch file, what we should expect it to do is to spawn a robot, which is defined in this robot URDF file, spawn it into the Gazebo world in the coordinates 0, 0 and 0.5 Z coordinate. Yeah? So let's run, let's put Gazebo right here so that we can see what's going on, and let's execute this command. Ekaterina is asking, what about Gazebo ignition? Is the spawn process similar? Yeah, it's pretty similar. Yeah. Also in ROS2, also it's pretty similar. You also use a node, which is a spawn something, or spawn entity, or something like this. Also, I don't remember right now exactly, but yes, the processes are similar. And voila! So here we have our robot spawned into the world, yeah, and we have spawned it using our ROS node, which is this spawn model. All right. Then we can have a quick look, if you want, at the URDF file, very quick, because it's not really the purpose of this. But yeah, basically you can see that this is a very basic mobile robot with this chassis, a couple of wheels, also a caster wheel. I don't know if it has one or two caster. Yeah, it has this front caster wheel there. So let's have a very quick look at the URDF file. So the URDF file, you can find it here in the same package, raw description, but in the URDF folder. And it's right here, robot.urdf. So if you double click here, you're going to find the contents of this URDF file, okay? Then we can have a look at, yeah, so here you have the basic structure of URDF file with links defined. Here you have the definition of the link chassis, yeah? With a joint that connects the link chassis to the caster wheel, another link for the caster wheel, of course. You are going to find also links, well, these are joints, but you are going to find links for the left and right wheels, all right? Here you have for the right wheel, and then, of course, you have all the joints which are connecting the different links. So in this case, you have the joint which connects the right wheel to the chassis, right? Up here, you are going to find the joint which connects the left wheel to the chassis, etc. Okay? This is basic URDF stuff, link definitions, joint definitions, etc. Okay, so I'm not going to go too much into it. You can see that we are using some meshes as well for the wheels, etc. What we can have a look at is at these Gazebo tags. Yeah. So, for instance, here is where we are defining the color of the chassis, right? We are defining the color of the chassis, or the color of the caster wheel, or the color of the wheels. Yeah? So if we change this to another color, like for instance, I don't know, red, we should see the color of the chassis change. Okay? So let's do one thing, and let's just stop everything for now. Let's just stop the empty world. I'm going to do this. You don't have to do it, okay? This is only for demonstration purposes, but you don't have to do it, okay? Because afterwards, I'm going to put it back to blue, and that's all. So I'm going to start again the empty world. There we go. And now, if I spawn my robot again, I should see the chassis in red. See? Yeah, so I am controlling this using these Gazebo tags, okay, and specifically the material. Also, you can see the moves defined, which are the frictions, yeah? So these moves are defining the frictions of the, in this case, the wheels or the caster wheel. Yeah, so the caster wheel has no friction because we wanted to have full free movement. And for the left and right wheels, we are defining some moves here. Yeah. Yes, we can use any. Is there any way to make the raw definition graphically and then get? Yeah. There are some tools that can do that. Yes. definitely. I know also, so Shrikar is suggesting cat. I think that you can also do that using SolidWorks, for instance. There are different tools where you can create the URDF graphically and well, the robot model graphically and turn it into URDF. You might need to do some adjustments later and so on, but yeah, there are some tools that allow you to do that. All right, so yeah, let me get my chassis back to blue so that we have all of us the same, and then we can keep moving. Yeah. So basically, I just wanted to make clear that with these gazebo tags, we can control some aspects related to the gazebo simulation. Okay, like the frictions of the links, the color, well, the material in this case, etc. Okay, and we are going to see another one at the end of the class. So yeah, let me get back to it. Start the empty world. Well, in this case, I'm going to start only the empty world for the next demonstration. Okay, so we are going to move to step 2, which is Gazebo's ROS node. Okay, then for this you can use the empty world only, or you can leave it with the robot if you want. It doesn't matter. Okay, so the thing of spawning a model into Gazebo is that, so in ROS we are going to have the Gazebo simulation represented by a node which is named Gazebo. Yeah. So for instance, if right now we run here a ROS topic list, we are going to see this. No ROS topic, sorry. ROS node list first. Yeah, ROS node list. We are going to see that we have this Gazebo node and also the Gazebo GUI in this case. Yeah, but the important one is this Gazebo node, which is the node that represents the Gazebo simulation in ROS. Okay, then we can have a look at this graph using the RQT graph, which is pretty interesting. So we can run here RQT graph. In case of sensor integration, does colors matter in Gazebo? Well, depending on the sensor. So if you are using an RGB camera where the color is important, then yes. If you are using a laser where the color doesn't matter, then no. But yeah, so if my robot has a Kinect sensor, for instance, I'm going to see the different colors. Yeah. So it does matter. All right. So we are running this RQT graph node. Then in order to visualize it, we have to come here to the graphical tools. It's this icon that you have here, which it looks like a computer screen. Then if we maximize this, we are going to see the nodes connection, which are not there. What am I seeing here? Oh. Okay, so where are my... Oh, I need to refresh here. Let me see. Gazebo. No, I cannot see it. Okay, let me see if I need to specify some... Yeah, I also got that before. Okay. Let me see if I can. Oh, maybe it's because I need to spawn something into the world. Let me see. So if I put something here, for instance, let's say, let me put here a block. It shouldn't be, but I don't know. No, so I don't see anything. Nodes topic is active. Okay, let me try spawning the robot. Well, no, it's not going to work like this. What if we do it with the robot on the world? Will we see some connections? Yeah, so I should be seeing some connections anyways. I don't know what I'm not seeing them. Victor says, yeah, it's working after spawning. Well, in any case, it's not that important. It's just a visualization tool, so don't worry if you don't see anything. Okay. Okay, so I don't see anything. I'm not sure why. Gazebo. Yeah, no. I don't see anything. Okay, don't worry. In any case, it's not that important. So let me keep moving, because what is important actually is that we see these connections, and that all this is. I see the topics, but not in the graph, just as you. Yeah, so basically, if we run here a ROS topic list, okay, we are going to see all these Gazebo link states, Gazebo model states, yeah, that you have here. Gazebo model states, Gazebo link states, also Gazebo set link state or set model state. Yeah, Gazebo set link state, set model state, parameter updates. So you have all these. So basically what this is saying is that we have the Gazebo node, which provides the model or the link states, and that we can send messages, let's say, to this node by these topics, set link state or set model state. And by using this, we can alter or modify the status of the model or specific links in the simulation. Yeah? So let's see an example, for instance, with a, we can run an example with this, but I'm going to do it with a simple box, for instance. So if I spawn a simple box here, yeah, we are going to see that this box is named here in the models list, yeah, right here in the left area of the Gazebo client, right here. You can open here the models, and you are going to see that we have the ground plane, which is this grid that you have here in the ground. It's like the floor. It represents the floor. And then we have this unit box, okay? Then we can, through ROS, through these topics, ROS topic lists, we can, for instance, change the state of the model, yeah? So, for instance, let's use, in this exercise here, let's use the set model state to change the state of this unit box model. So we can do this with a ROS topic pop of Gazebo set model state yeah. So if you autocomplete at this point, you are going to see that this topic, set model state, uses this message, Gazebo messages model state. Yeah, you can also get this but with a ROS topic info, right? Of Gazebo set model state. Yeah, so we can see here that the type used by this topic is Gazebo messages model state. So if we want to publish a message into this topic with ROS topic pop or by creating a publisher, we are going to have to use this type of message. So let's try to publish a message into this topic. Let's autocomplete here so that we get the message written here directly. Gazebo messages, it's model state. And then here, as reference frame, we are going to select the world. Yeah. So Gazebo has this world frame which represents like the zero of the like the 0, 0 coordinate, the center of the world, of the Gazebo world, let's say. Yeah. So we can select this world as reference frame, and then we can change, for instance, the position of our model. Let's change it to x of 2 and a y value of 2, for instance. So if we publish this message, nothing is happening, okay? Okay, let's see what's going on here. So, oh, of course, I think oh yeah, so I forgot to put the most important part, which is the name of the model. Yeah, which is the first field here. Of course, if I don't specify which is the model that I want to set the state, it's not going to happen, right? Yeah, no, Kyle, I forgot to write the model name. Yeah, so this is the most important field. So the model name, for instance, in this case, we can get it from here, from the GUI, okay? There are other ways in which we can get it, like, for instance, with a service, but we are going to see this in a moment, after we do some tests here with the topics. So, yeah, in this case, the name of the model is unit_box, right? So, if I want to publish a message, I need to, of course, specify the model name, which is the very first field right here. So, unit box, right? So, let's do this. And let's publish this message. And again, nothing is happening, okay. Okay, let me see. Or maybe I don't need the... Oh, okay, I see now. Yeah. So, yeah, Kyle, you are right. I'm blind. So I am publishing into this Gazebo topic. Damn it. Yeah, I'm really blind. Okay, so let me fix that. Thanks a lot. All right. Yeah, I'm blind. And this is happening because, yeah, so there you go. Now it works. So yeah, you were totally right, Kyle. Thanks for spotting that. Yeah, so this happens because I am not autocompleting, right? So if I were to autocomplete with something like this, if I click double tap to autocomplete, as you can see, nothing happens. Yes, so this is why it's a very good practice to always try to autocomplete your ROS commands. Yeah, because it's a way of avoiding this kind of errors, right? Because like this, if I try to autocomplete, yeah, this doesn't work at all. But if I write it properly, ROS topic, pub, Gazebo, if I try to autocomplete now, then it does work, right? As you can see. So yeah, thanks for that, Kyle. And yeah, so you can try some things here or here. We can use the world frame. If you don't specify any, I think that by default is going to use the world frame. So let's try to move it back to the origin, to the 0, 0 coordinates, like this. Yeah, okay. So specifying world or not, in this specific case, it doesn't matter, yeah? But here, in any case, for more complex simulations, you can specify the reference frame of your new state, of your position, yeah? Okay. Then, yeah, so we have these topics, which are provided by Gazebo, where we can set the model state, the one that we have just seen. We can also set the state of a particular link. For instance, this can be useful for an arm, a robotic arm, for instance. Yeah. And yeah, of course, we can also get, so if we subscribe here to this topic, ROS topic, echo, Gazebo, model states, we can subscribe to this topic in order to get the state of the models. Yeah? So we have the name, ground plane, and unit box, and the pose. Yeah. Then, also, besides these topics, we have also some ROS services, which are provided by Gazebo. Yeah, which are the most common ones to interact with. So, one of the services, well, first of all, let's do this. Let's do a ROS service list, right? So that we get a complete list. As you can see, there are many services. Yeah. So we have apply body branch, joint effort, clear body branches. Well, we have many different services, ROS services, which are related to the Gazebo node. Okay. Then we are going to have a look just at some of them. One of them, for instance, is this spawn URDF model. Yeah, you can see it here. Where it is here, spawn URDF model, or even spawn SDF model. So you can use these services to spawn a URDF into the Gazebo simulator, just the same that we have done here in our launch file, right? So it's basically the same. We can use this service, and we are going to have to specify a URDF file, coordinates where to spawn, etc. Yeah? However, for this kind of service, like the spawn URDF model, usually this is handled through launch files. But for testing, debugging purposes, etc., you can make use of it, of course. And there are other services like pause and unpause physics, for instance, or reset simulator and reset world, which are also very useful. Of course, pause physics and unpause physics, what's going to do is to basically pause the physics of the world. Yeah, it's basically the same of clicking on this pause button. Yeah, this is the graphical way of doing it. If I click here on the pause button, this is going to pause the physics, right? So for instance, if now I move my cube up here, it's going to stay here floating, right? See, it's floating. Why? Because my physics are paused. So as soon as I activate again the physics in my world, the cube is going to fall because of gravity, right, to the ground. So as soon as I click play, the cube falls. Okay, and I can achieve this same behavior, for instance, by using the pause physics service. So let's do a call here through the terminal. ROS service call Gazebo pause physics. Let's autocomplete for the message like this. All right. So right now I have paused the physics. As you can see in the GUI, they show like paused again. Yeah. So again, I can do the same experiment, which is to move the cube up like this, and then now, if I call the unpause physics from the terminal, what should happen is that this cube is going to fall to the ground, right? Let's do it, and there you go. Okay. Another very useful service is this reset world, for instance. Yeah. So basically, this what's going to do is after many changes that you can do to the world, like moving the cube here and etc. So if you want to set things back to their initial position, yeah, set all the models' position back to the initial one, you can use this reset world service. Yeah, which is going to, let's do a test here. ROS service call Gazebo reset world, and again let's autocomplete for the message, and this is going to move the model back to the initial position where it was spawned. Okay. Yeah. Of course, this can be done also from the GUI. Yeah. So if I move this here, I can come here. In this case, it's to edit and reset world, for instance, or reset model poses. Yeah. If you click reset model poses, it's exactly the same. Yeah. So let me just show a couple of extra services that are also interesting, which are not listed here in the notebook. Like, for instance, is the get world properties. Yeah. So we can call this ROS service call Gazebo get world properties. Autocomplete for the message. Most of these messages, as you can see, use just empty messages, yeah, for the request. So you can call this service to get very quickly a list of the models in the simulation, which is the ground plane and the unit box right now. Yeah. And also you have the set model state, for instance. Yeah, so you can also use this ROS service call Gazebo set model state service. Let's autocomplete again for the message. Yeah, and we can again, from this service, change the state of a specific model. So let's select here the model name unit box and change its position to X3, for instance. Yeah. So if I do this call to the service again, I should see the position of the robot the model, of the unit box model changing, as you can see. Okay? Yeah? So not right now, because now we are going to move to the next section, but I encourage you to have a look at and play a little bit later, okay, with all these services, okay, and do tests, do your own tests. For instance, try to spawn some random URDF using the spawn URDF model service, etc. Okay, so after this class finishes, as I always remember, you are going to have this rosject in your account forever, so you are going to be able to relaunch it tomorrow or the next month. Okay, so I encourage you to have a look and do some tests with all these services so that you get a better idea. Okay? Yeah? So far, some questions until this point, or shall we move to the final part of the class? No question, says Johnny. So basically, the main idea of this is that you are aware and you know that you can interact with the Gazebo simulation by using ROS topics or ROS services also. Okay, so whenever you you launch a Gazebo simulation using ROS nodes, using a ROS launch command, etc., you are going to have this Gazebo node, and you are going to have some topics and services available so that you can directly interact with the Gazebo simulation from ROS. Yeah, by using, as I said, ROS topics and ROS services. Okay. Then, and yeah, this is a very important connection between Gazebo and ROS, and you are going to be using a lot these services and topics especially for debugging and for checking out issues that you might have on your robotics projects. Okay, so it's very important that you know about this. All right, then the final thing that we are going to be checking at is about the Gazebo ROS plugins. Yeah, so there are many plugins that you can use in order to for instance, simulate in Gazebo sensors or actuators, okay? So for instance, you can use Gazebo ROS plugins for lasers, for simulating a laser, for simulating an IMU sensor, or in this case, we are going to represent a differential drive, okay? So we are going to use this plugin, which is very widely used, and it's one of the most populars, let's say like this, which is the differential drive plugin, okay? So by specifying this plugin into Gazebo, I'm going to simulate with my robot. Well, first of all, I need to spawn my robot again. So let's get rid of this cube in case that you have it already here. Let's get rid of it. Let's remove it. Oh, by the way, I'm going to do one last thing, which comes very handy, which is, so as you can see, now I have just deleted this model by right-clicking on it and selecting delete, okay? So, for instance, of course, you have a service which is used to delete models from the simulation. Also, very useful service, which is this one, Gazebo delete model. So I can use this service like this, ROS service call Gazebo delete model. I'm going to autocomplete to get the type structure, and then just by specifying the model name, which in this case it's unit box, yeah, I can get rid very easily by using this ROS service. I can get rid of this model here in the simulation. Yeah. Okay. Then yeah, so let's spawn. Well, let's not spawn yet. We are going to spawn it after doing the proper modifications. Okay. So this differential drive plugin is going to allow us to move our wheeled robot by publishing into a ROS topic. And also it's going to provide us automatically a ROS topic with the odometry of the robot. Yeah, so it's a very, very useful topic because it simulates odometry for our robot so that we can get access to this odometry data. And also it provides a topic which usually it's going to be called CMD bell, command bell, where we can publish twist messages in order to move our robot. Yeah? So what we are going to do right now is to add this piece of code to our URDF file, okay? So we are going to copy it directly from here, copy it from the notebook, copy, and then we are going to come to our URDF file, yeah, robot.urdf. Let's add it here at the bottom. Let's go to the bottom of the file, and right here, before the closing robot tag, right here, we are going to paste our plugin. Yeah? Let's fix here the tabulations like this. There we go. Yeah? So we're going to add at the end this extra Gazebo tag with the plugin of the ROS differential drive, okay? Then you're going to have to define some things in this plugin depending on the robot you are using. So you have to define the name of the left wheel joint, the name of the right wheel joint. You need to specify the wheel separation, the value, the separation between wheels, the wheel diameter, a torque. Here is where you specify the name of the topic that you want to use in order to send velocity commands to your robot. Yeah? And also you specify here, for instance, the name of the topic where you want to publish the odometry data and the name of the frame. If you change, Arnoud is asking, if you change the URDF and do reload world, will it read the new URDF or do you have to restart Gazebo? No. It's not going reload world. What do you mean? Restart world? Reload world? Do you mean this? Do you mean the service restart world? This one? Reset world? Yeah, no. So if you change, no. So this reset world or reset simulation, what's going to do is to reset the current models to their original positions, the positions where they were originally spawned at. Okay, the reset world only does this, and the reset simulation, it also resets the simulation time. Okay, but no, if you change the URDF like we are doing and you use this service, it's not going to get updated. Okay, so you need to remove the model and respawn it in any case. Okay, so if you want to do everything from the command line tool, you would have to delete the model of the car and then respawn it using this service. Okay. Why? Because this data, this new data of the plugin is going to be loaded into the robot description parameter. Okay? So we need to load this new information into the robot description parameter so that the spawn model knows about this information. Yeah? Does it make sense, Arnoud? Do you see? Does this answer your question? Okay. And there was, I don't think it does, but does it matter where you define plugins etc. within the URDF? For instance, at the top or the bottom of the file, or does it not matter as you specify the tags? And yeah, it doesn't matter, Kyle. It doesn't matter. It doesn't matter. So usually, what are the plugins written in XML format? Well, this is added using XML format, but the source code of this it's written in C++. Okay, so the source code of this plugin is C++, but to add it here to the URDF, you use XML, yeah, like this. And usually you would separate these Gazebo tags from the regular URDF file, okay? But this is a pretty simple example, so we have everything into one single URDF file. Usually you would separate the plugins from the link and joins definition, okay? So you would create here a separate file, which is robot, for instance, .gazebo.urdf, and then you would define here the plugin, for instance. Also, you would define here the Gazebo tags, basically, okay? But in this case, we are doing everything into one single URDF, just to simplify things. But for more complex projects, you are going to usually find these in separate URDF files, okay? And then these separate URDF files are going to be included into one main. Yeah? Okay. Then, yeah, so let's update our URDF file, adding the plugin data here. And then we are going to restart our, well, I don't need to restart right now because I have already my empty world here. So what I'm going to do now is to spawn it. So ROS launch, robot description. Well, let's do one thing. Let's see the difference between having this and not having this, okay? So I'm going to comment this right now here. I'm going to comment it out. Okay, so ROS launch, robot description, spawn. This is going to spawn the robot in the simulation. And there we have it, okay? And now, for instance, if I do a ROS topic list here, I am going to see I have clock, I have some topics related to Gazebo, which we have already checked, and then just ROS out statistics, okay? So we don't have anything related to odometry or velocity, which is common bell, okay? Then let me now very quickly uncomment this code. Okay, let me uncomment this. I'm going to delete my car, okay? So I'm going to do that using services. ROS service call, for instance, I'm going to use the get world properties to get the name of the model. Get world properties to get the name of my model, which is my robot. And now I'm going to use ROS service call Gazebo delete model to get to delete the current model, which is my robot. There we go. And removed, okay? And now I'm going to spawn it again. Yeah, let me make sure that I have uncommented, yeah, I have uncommented the plugin code. So let's respawn again now the robot. There we go. Okay, and now if I run again ROS topic list, I'm going to see that I have the common bell topic here available and also the ODOM topic. So if I subscribe, for instance, to the ODOM topic, ROS topic echo, sorry, ODOM, I'm going to get odometry data from my robot right away, okay? And also, I can publish messages into the common bell topic. For instance, ROS topic pub common bell which uses geometry messages, twist, okay? And then, for instance, if I specify a linear velocity of 0.1, my robot is going to start moving forward, right? There you go, okay? Oops, sorry. So let me stop it. Can we write plugins in Python, or does it have to be, yeah, for plugins, I think, I'm pretty sure it has to be with C++, Sagar, to write plugins, okay? I'm not 100% sure, but I'm pretty sure that you have to do it in C++ currently. So there is no Python API available for writing plugins. Haven't seen where is your shared library located. So I suppose that you referred to this, right? Lib Gazebo ROS div drive. So this is this one is installed by default. Yeah. So this shared library for the differential drive plugin is installed by default with the ROS installation. Yeah. This is one of the default plugins provided by ROS. So specifically for this, you can have a look at let me see. It's sorry. Grep Gazebo. Yeah, so if we have a look at the, if we have a look here at the Gazebo environment variables, you're going to see here one variable which is Gazebo plugin path, okay? So whenever you specify a plugin file name here, Gazebo is trying to look for it in the paths specified here in the Gazebo plugin path. Okay? Yeah, that's it. Gazebo plugin path. So if you define your own custom plugin in your package, etc., at the end, if you want to use it in Gazebo, you would have to add your path to the Gazebo plugin path so that Gazebo can detect your library. Okay? So, so yeah, basically that's it. So here at the end, you have a very simple Python code where you can test the odometry topic and command belt topic, but we have already done that directly by publishing into topics. So, so yeah, I'm going to leave it here and encourage you to keep working on this rosject and do some tests with the different services, topics that Gazebo provides. You can also play a little bit here with the graphical interface to do different tests. And yeah, just remind you that in case that you want to keep learning and get a more advanced knowledge on Gazebo, on many different things, we have this new Mastering Gazebo Simulator course where you are going to learn about, for instance, building a robot from zero to Gazebo, all the different connections with ROS. You are going to learn about using different plugins like laser plugin and different Gazebo plugins. You are going to learn about building Gazebo worlds from zero or writing your own Gazebo plugins. Okay? So, yeah, from my side, I'm going to leave it here. Thanks a lot for being in another class with me. Well, actually, before finishing, let me do one last thing. I always forget about this last step. Give me just 20 seconds. So what I want to do here is to activate here the rate form. Let me do it now in 3, 2, 1, and go. It should appear right here a rating form so that you can rate this open class if you liked it or you didn't like it. Okay, give it a score so that we can get some feedback from you and keep improving and making better open classes in the future. All right. So yeah, with this being said, thanks a lot again for being here with me in another open class. I will see you next Tuesday with next open class. And if I don't remember wrong, we are going to be talking about ROS2 again. We are going to go back to ROS2. So yeah, stay tuned for news and more information on the next open class. And as always, take care and keep pushing your ROS learning. Bye-bye.